Hello, welcome. Today, we're diving into multi-threading in PHP. Many think PHP is strictly single-threaded. It's true for basic web requests. However, we can use extensions to achieve concurrency. This allows us to run tasks in parallel. This can dramatically improve performance for certain applications. Let's explore how to do it. First, let's understand why we need multi-threading. Imagine you have a PHP script that needs to process many images or download several files. If done sequentially, this takes a long time. Each task waits for the previous one to finish. Multi-threading allows you to start these tasks simultaneously. This significantly reduces the overall execution time. Think of it like having multiple workers instead of just one. They can all work on different parts of the same job at the same time. Now, how can we achieve this in PHP? The most popular extension is Threads. Unfortunately, Threads requires the thread-safe version of PHP and has some restrictions. So, we will look at other more viable approaches. One way involves creating processes. PHP's proc_open function allows you to launch external processes. These processes run independently of the main PHP script. They can execute tasks in parallel. You can then communicate with these processes. This approach provides true parallelism. It's not threading, but it achieves the same result of concurrency. Another technique involves using message queues. These queues allow different parts of your application to communicate. One part can enqueue a task, and another part can process it asynchronously. This is useful for handling background jobs. Tools like RabbitMQ or Redis can facilitate this. They are robust and scalable. Let's consider a practical example. Suppose you are building an e-commerce site. When a user places an order, you need to send an email, update inventory, and process payment. Doing these sequentially would slow down the user experience. Instead, you can use message queues. Enqueue tasks for sending email and updating inventory. A separate worker script processes these tasks in the background. This ensures the user doesn't have to wait. They can immediately see the order confirmation. This also helps to handle spikes in traffic gracefully. Remember that while using threads or processes, be cautious about shared resources. Ensure proper synchronization mechanisms. This prevents race conditions and data corruption. This is crucial for maintaining data integrity. Always consider the overhead of creating and managing threads or processes. For very short tasks, the overhead might outweigh the benefits. Profiling your application is essential to identify performance bottlenecks. Multi-threading is not always the solution for everything. Carefully assess if the performance gain justifies the complexity. Consider alternatives like caching or optimizing database queries. Multi-threading or multi-processing introduces complexity to your code. Thorough testing is important. Debugging threaded code can be challenging. Employ logging and monitoring to track the execution of different threads. This will help in identifying and resolving issues more effectively. PHP is evolving. Newer versions introduce asynchronous programming features using libraries. These offer alternative ways to achieve concurrency. Stay updated with the latest developments in the PHP ecosystem. Experiment with different approaches. Choose the one that best suits your application's needs. That concludes our overview of multi-threading in PHP. I hope you found this informative. Thank you for watching. If you enjoyed this video, please like, share, and subscribe. Your support helps us create more content like this. Consider checking out our other videos for more PHP tips and tricks. Let us know in the comments if you have any questions.